Welcome. In this module, we are going to take a look at NoSQL databases. So first, we'll take a look at what initiated the birth of NoSQL databases and what were some of the shortcomings of relational databases. And look at types of NoSQL databases. NoSQL databases can be put into 4 different categories. And in this module, we are going to take a look at explore 3 out of the 4 different types of NoSQL databases. Alright, so let's get started. The birth of NoSQL databases. So NoSQL, where does this term arise from? It actually arose in a very interesting way. It was just a term that was coined by a lot of meetups that were talking about different non-relational databases. Right, so NoSQL refers to, it's a blanket umbrella term that is used to refer to number of non-relational databases, and it was retroactively interpreted as not only SQL. So there are multiple driving forces behind the evolution of NoSQL databases. One of it was the need for highly scalable databases that manages very large data set and high write throughput, right? So with the advent of social media, there was a lot of data that was coming in and there was a need to write it. So there were limitations that were faced by relational database. There was a need for specialized query operation that was not supported by relational database models. So if you remember the relational database models, you have a lot of joins which help us to look at logic across multiple entities. But then there was also a need for looking at relationship and then the number of hops with regard to the relationship, etc. So these were not supported by relational models, or it got very complex to be supported by relational models. Of course, with the growth of multiple data sources, there was increasing frustration over the restrictiveness of relational schemas and the desire for more dynamic, flexible and expressive data models, right? So the relational database models are a little bit more rigid and it needs to be established before the application was developed. But then with faster application development, there was a need for flexible schema which can be changed quite frequently and as often based on the software needs and features that were developed. And of course, one another driving, very important driving factor is the rise of free and open source software over commercial ones. Alright, so it's very important to understand as we go through this journey of understanding NoSQL databases, we will constantly be comparing with relational databases for a lot of reasons. One reason being relational database is existed for a long time, right? So in a lot of applications you will see that there is something called a polyglot persistence, which means relational databases will be used alongside non-relational databases. So the NoSQL databases were not used, were not developed as a replacement for RDBMS, but it was used, it helps us to have a lot of flexible data models for specific applications and to be used concurrent with relational databases, right? This is a point that is important to remember as we go through understanding NoSQL databases. So before we sort of dig into some of the advantages of NoSQL databases, it's important to understand the database model versus objects in an application, right? So till now we have been talking about the database model. There is a very important problem that exists in relational databases, which is called the object relational impedance mismatch. So what does this mean, right? So in the back end, there is a database model where you have your entities which are physically represented as tables, and then the attributes represented as columns, and each row corresponds to a particular entity, right? Whereas when you are writing an application level program, the software side of it, softwares, because of the increasing advantages of object oriented programming languages, your OOPS languages, objects in the application code were written using object oriented programming languages, right? Your C++, Java, etc. Right? So that is the application side. So there needed a translation layer to convert your data model to be used by this application, right? Because data model was in the entity relationship space. So data models were created that way, right? Whereas the application looked at it from a business centric point of view. So this is what is very important to understand, that there was this mismatch between how data was represented in its physical form in the database and how it was used in an application, right? So some of the times objects that were created in the application code was based on how the business perceived those objects, right? They didn't correspond to entities, right? So there was need for translating the data model into the corresponding objects in the application code. This specific problem is called the object relational impedance mismatch, and NoSQL databases are one way in which one can solve this problem, right? So as we discuss more, we'll we will take a deeper look at this problem. With the advent of NoSQL databases, they did start growing in popularity. So why was NoSQL databases getting more popular? Is because of their fast scalability, right? Their high scalability. They were essentially constructed as a distributed system, right? So they were meant for a very fast application and are also designed as a distributed computing system. So they were fast and they were also scalable. So one of the key things that happened with the latest web applications that started coming in, like social media applications, etc., was there was the traffic of people went high and low, right? So there was need for a database which will cater to these flexible needs, and it also needs to be distributed across different geographical regions, etc. Another reason for its popularity of NoSQL databases is its schema flexibility, right? One of the things that we saw in the last slide is so there was a need for faster feature development, faster application code development, right? But because of the object relational impedance mismatch, it was the development of software was becoming a tad bit slower, because there was a need to go back and look at the data model and change it, right? Whereas NoSQL databases, we will see as we explore them, gave high schema flexibility. So as new features got evolved, then different NoSQL databases could be used for specific needs. So reiterating on that point, right? So NoSQL databases are typically schema-less, which means they store unstructured or semi-structured data, and it essentially solves the object relational impedance mismatch. So how does it solve? Because your physical data model was close to the application data model. So because of this, what happened was there was faster software development that was happening. So finally, NoSQL databases, one thing to remember is it is not meant as a replacement for relational databases. So NoSQL databases involve no complex relationship, right? So there was no joins required, no joins supported in NoSQL databases. So all in all, NoSQL databases are the set of databases, right? We are going to see what they are. These were the set of databases that were actually built for the 21st century web, right? Because it was fast, it was scalable, it was schema-less, and it made sure that the application development was fast because of no complex relationship. So now let's take a look at some of the types of NoSQL databases. So there are 4 popular types of NoSQL databases. One is the key value store. Some flavors of key value store are Redis, Aerospike. Then you have the columnar database. Some examples of that are the Cassandra, Azure Cosmos DB, Cosmos DB. Then the graph database. So you have graph database, the Neo4j are graph databases. And then finally, document databases, MongoDB, CouchDB, etc. So we are from the images, you can get some insights into what each of it focused on. So we'll dig deeper into each of these different types of NoSQL databases. So in this module, we are going to look at the top three: the key value store, columnar database, and graph database. Because document database needs a little more attention, we will deal with it in the next video. So now let's look at each of these NoSQL databases. So key value store. So key value store is very synonymous to what the name itself says, right? So key value store is a storage system that stores value that are indexed by key. So we have seen a typical key value store in a dictionary kind of data type in Python, right? So there is a key and there is a value. So the value essentially is opaque to the application. So the value gets indexed by the use of the key, right? So you have here, you can see the example. You have user one, the corresponding value details of user one, etc. Alright, so once you have these key value, you realize that there are multiple CRUD operations. So CRUD operations, as we have seen, refers to your creation of data, retrieval of data, updation of data, and deletion of data. And everything gets done with the use of the key. So when you're putting data in, you put together as key and value. So the application can directly write to the key value database. So you're retrieving data using the key. You can delete data by using the key. You can also update the data using the key. So some of the advantages of this key value store, it's a very simple data model. It just has two values, right? Unlike your table which has multiple entities, columns, etc. It's a very simple data model which has key and value, and the value can represent any information, structured, unstructured data, etc. So query by the key and the values are opaque to the application. So they are very, very fast because they are indexed by the key. So you can essentially get to the data very fast, right? There is no complex relationship here. So very fast read and write operations like non-volatile cache, right? So key value stores tend to get used in some case for caching applications. When you want to store large amount of data, right, and you want to keep it for faster retrieval, then key value stores are typically used. So of course, it doesn't come with, there isn't only advantages, it does come with a bunch of disadvantages. Key value store may not be suitable for large volume of data, right? So if you're using terabytes of data in the value, then it's going to cause a lot of problems in retrieving the data, right? So it is used mostly for caching applications. So we'll see some of the ways in which key value stores are used in applications. Right. So one of the other things, some of the properties of your RDBMS systems are not valid for key value store. One of the key property is called the ACID property. It stands for atomicity, consistency, isolation, and durability. We'll take a deeper look at each of these properties later. But it's important to understand key value store, to reiterate, is not a replacement for your RDBMS, because some of the data consistency, etc., which is relevant in RDBMS may not be relevant in your key value store, and it is a very simplistic data model. As you can see, it may not be capable of any complex applications. So next, let's look at columnar database. So columnar database, the name itself sort of gives away what it represents. So in a typical relational databases, your data is stored in a row-oriented fashion. So what does that mean? A table contains multiple columns, the different attributes of the entity, and each row corresponds to the entity, right? Whereas a column-oriented database is where data is stored in terms of the columns, right? So the row ID and the columns tend to be stored together. This is specifically becomes a lot of advantage when you have a large amount of data, big data to be stored, right? Because it helps in compressing your data. So let's take a look at how. So columnar database is a database management system that stores data tables by columns rather than rows, as you can see in this image. So we'll take a deeper look at how the columns get actually stored, right? So here, because columns have to be together with the rows. So here you will see that it provides a very efficient access to data when only querying a subset of the columns. So you are not essentially going to, as you can see, columnar database is not typically for applications which does select star from a particular table, right? Because your data is distributed across multiple columns, right? So when you have data, when you are looking to analyze only a particular column, right, then columnar databases are super fast, right? So it's an efficient way of accessing data when you're querying only a subset of the column. So you are doing analysis on, let's say, the GPA value here, then you want to look at columnar database. So because of the way the data is stored, columnar databases are well suited for analytic workloads where large number of rows are scanned, whereas a relational database is better for a transactional workload where smaller number of rows are manipulated. So what do we mean by analytic workload? When we are looking at analytic workload, what we are looking at is, hey, we want to find the average GPA across a bunch of the set of all students in a particular institutions, etc. So they are all, so you need to aggregate data, right? Or if you want to find the maximum value, the minimum most score across an institution, across a certain time period, etc., right? So typically you're doing a lot of aggregation function when you're doing analytic workloads, and columnar database works very well for these analytic workloads, whereas your row oriented relational databases are better for your transactional workload where you are inserting your rows, right? You are inserting the name, the GPA, etc. from a software. So then you want to use your row oriented database. So some of the flavors of columnar databases is your Apache Cassandra, your Azure Cosmos DB, etc. So for your columnar database, we use, so there are different query languages that are used. One of the very popular query language is called the Cassandra query language, that stands for CQL. So let's take a deeper look at the columnar databases. So in a columnar database, mapping of data is different. How is it different? In a row-oriented database, the indexes map the column values to the row IDs. Whereas in a column-oriented database, the column maps row IDs to column values, which results in better data compression. So let's take a look at this table, right? So you have your row ID, employee ID, last name, first name, and salary. So a typical row-oriented store essentially stores it in a row-wise fashion, right? Your row ID is 001, followed by the column values 10, Smith, Joe, 60,000, and so on. Whereas a column-oriented store essentially has to store the row ID and the column value together, right? So here if you look at it, you will see that your employee ID 10 for the row ID 001, then employee ID 12 for 002, 11 for 003, and so on, right? So the first is just your employee ID column. Then comes the next corresponds, because it's storing it in column wise fashion, right? So you have your Smith, Jones, Johnson, and Jones stored together. So each of the columns is stored in a specific way, and it has to be associated with the row ID, because you need to be able to connect which row corresponds to which column. right? So because of this, you will see there is data compression that has happened even in this small database. So your columns map row IDs to column values, right? So each of it maps the row ID to the column value. So here you can see, because of the essential Jones being used twice in the last name column, so you see your Jones value, right? You can represent it with two row IDs, 002 and 004. So by essentially trying to do these kind of tricks in terms of storing your data, you will see that columnar databases are very efficient in compressing data, large amount of data. So in a columnar database, the key concept is called a key space. Okay, a key space contains all column families, which contains rows, which contains columns. Although it does seem like a tongue twister to start off with, right? So let's take a visual example of it. So in a columnar database, the columns are stored through column families. Okay. So the set of all column families are essentially called the key space. Okay. So if you look at this image, you will see the column family, right? So each row tends to have varying lengths of column values, right? So the first row of the one at the very top left hand corner, you see that it's shorter, and your second sort of row has a longer, more number of columns. So this you can see across these multiple column families, right? So if you look deeper into each of the row, right? So so here the rows are storing user profile information. So here the first user has three columns: the email ID, gender, and age. Whereas the second user, Brittany, has only email ID and gender. Whereas the third user, Terry, has email ID, country, hair color, so on and so forth, right? So that's why you can see that different rows tend to have different set of columns which are connected, and each row is identified by a row key, and there are specific number of columns in it, right? So the row key is a specific identifier of that row and always unique. The column contains the name, value, and the timestamp. So the name value pair is straightforward, and the timestamp, the date timestamp is essentially when the data was entered into the database. It helps to understand columnar databases when we look at the query language, right? So Cassandra query language, SQL, is essentially the query language to communicate with the Apache Cassandra database. It's a NoSQL query language. So in a NoSQL query language, you just write your query. It's a declarative language. So it is capable of querying across horizontally distributed servers and clusters that are massively scaled and manages unstructured data. And they avoid joins and are easy to scale, right? So each of these queries, remember, it's being executed across horizontally distributed servers, right? Which store essentially some semi-structured and unstructured data. So the typical Cassandra query language, to sort of give you a sense with regard to the SQL that we are familiar with, right? SQL. The key space corresponds to SQL database. The column family corresponds to the SQL table, right? And then the primary key is a combination of your, there is a row or partition key with the cluster key. So what the primary key does is it helps to uniquely identify internal rows of the data. So the row or the partition key determines the node in which the data is stored, because remember, it is distributed, your databases. And the cluster key determines the sort order of the data within a particular row. Okay. So you will see that some of the properties of RDBMS has also, because of its popularity, has been extended by creating these query languages, because you want to have SQL-like query languages, so that because for a long time RDBMS has been very popular, and SQL being the query language, people are more familiar with it, right? So that's why you will see that a lot of query languages are SQL-like, right? So it will have similar rules such as SQL. So what are some of the pros of the columnar databases? So in columnar database, the greatest advantage is data can be highly compressed, which permits columnar aggregation operation, as we saw earlier, right? So because we are trying to do data aggregation, when you are trying to do analytics workload, you are trying to do aggregation like minimum, maximum, sum, average, count, and they have to be done rapidly over terabytes of information, right? But they restrict to only a single column, right? Sometimes you are trying to look at the count of employees over a period of time, etc., or count of users who logged in between a certain period of time, etc., right? So you can see that how your aggregation, because your aggregation is only on a particular column, how columnar database can actually help to perform it very rapidly, and it also helps to store your data in a compressed form. So columnar database is said to be self-indexing, that uses less disk space than RDBMS, right? Because you can see, because of the way in which your column data are stored together, you can there is a more efficient way of storing your data. The columnar architecture does not read unnecessary columns, right? So you're not looking, so one of the greatest mind shift that you need when using columnar database is, it's not the entity and the column, because you're now trying to look at for a particular entity, the data will be distributed across multiple column families, right? So instead of a single table, right? So a columnar architecture is not does not read unnecessary columns, and they work well for queries that involve few columns, aggregation query against vast amount of data that is used typically in data analytics, right? So these are so only in these use cases columnar data will be better than RDBMS. So columnar data, so you can see that your transactional software will still need to use your RDBMS software, but your columnar database can be used for your analytic workloads, right? So what are some of the cons of columnar database? They are not efficient for online transaction processing application, because they are not good with updating transactions, right? So they are good at aggregating your columns in a lot of ways. So across the board you will see that NoSQL databases do poorly on join operations, because it's not designed for that, right? They perform poorer than your row based or row oriented database if the query pattern extract data from majority of the columns in the table, right? So if you are doing aggregation on a particular column, then columnar database would be more efficient. But in most of the cases you have to extract data from majority of the columns in a table, then you are better off using your RDBMS, because in a columnar database your data is stored in terms of the column, right? So if you are going to use multiple columns to search your data, that's going to take a lot of time. Some columnar systems greatly compress the source data, right? So when you're reading your data, uncompressing the data can result in slow performance, all right? So that is also something that we need to keep in mind. So now from columnar database, we'll move on to the next NoSQL database. So next we are going to look at graph database. Alright, so we have seen key value database, columnar database. Now we are going to see the third type, which is your graph database. So a graph database system shortened as GDS, is based on graph theory that use graph structures with nodes and edges to represent and store data. So the nodes essentially represent the entities equivalent to your ER diagram, and the edges represents the relationship between the nodes, and there are properties that you can associate. So both your nodes and your edges can have properties, information associated with nodes or edges. So a graph DB is aimed to mimic the highly connected real world data in a very intuitive way, right? So in a relational database, what happens is, although your entities are connected, we sort of flatten them out in terms of a table, right? The connection between the entities, we do have joins that helps us to approximate the connection, but it's difficult to see these real world connected data as such, right? In a graph database, it helps us to intuitively understand entities and how they are connected. So the query based on relationship is fast. So they are optimized so that the relationship, they are relationship oriented, right? So query based on relationship is fast, and they are perpetually stored in the database. So this is what, if you remember the first slide, we talked about some of the queries were restrictive, right, in a relational database, because when you are asking queries with regard to relationship, it's better to put your data into a graph database. So some flavors of graph databases is Neo4j, you have your Amazon Neptune, and your Tiger Graph. With regard to the query language, so you will see that there is multi-vendor query language. So different different graph database tend to have different query language. So Neo4j has Cypher, and then you also have SparkQL, which is another graph query language. In this slide, we are going to take a look at an intuitive graph database. So each node, the entity or attribute in a graph database model, directly and physically contains a list of relationship records that represents its relationship to other nodes, right? So these relationship records are organized by type and direction, and may hold additional attributes. So the database just uses this list and has direct access to the connected nodes, eliminating the need for expensive search and match computation, right? Your Cypher query would not be, because your relationship are essentially stored, persisted in your database. So each of these relationships are the ones which are catered more, right? So this ability to pre-materialize relationship into database structure allows graph database to provide minutes to millisecond performance advantage of several orders of magnitude, especially for join heavy queries. So in order to understand join heavy queries, right, because if you are looking at relationship, you are doing multiple joins in an RDBMS, because relationships are inherently stored that way. The resulting data model is much more simpler and at the same time more expressive than your relational database, right? So here you see graph database looks at certain looks at the data from a different perspective. So now let's quickly take a look at Cypher, which is the query language for Neo4j, which is a graph database. So Cypher can be used for all the CRUD operation. So you're creating a node, in this case a node called city with name and population, which are the properties, the nodes with relationship, right? So if you want to connect two cities, so you have city name UK and city name London, and you're trying to connect, right? So you can both create nodes with relationship. If you want to retrieve information, right? So you want to match city to a country node where the city name is London, right? So then you will get the corresponding match. So you can do retrieval, you can also do updating, right? So after you search match country where your country name is so and so, you set the country name to UK instead of United Kingdom. We are just updating your database here. And then finally, you can also delete your node along with the relationship. Right, so here you see that some of the cipher queries. So one of the key things that a lot of NoSQL databases are borrowed from SQL database is the SQL-like query. So you can sort of understand essentially what is happening here. So let's take a look at the pros and cons of your graph database. So some of the advantages is its flexible data structure. It's very fast when looking for relationship between nodes, right? So it's based on graph theory. So you can do a lot of other interesting things like traversing through the graph to see how many nodes we have connected, etc. Really fast to traverse the nodes. Can be used to represent multi-dimensional data, right? So any sort of complex data can be, because when you have different perspectives of the data, so you can create different relationships by storing it into a graph database. Whereas, of course, there are disadvantages as well. You essentially, one of the key things you will find interesting when working from RDBMS to graph database, it requires rewiring your brain from the RDBMS way, right? Of course, it becomes intuitive after you worked with it for a while, but the initial, there is a certain learning curve, right? It is inappropriate for transactional information where relationship between the nodes are simple, right? For accounting information, etc. You don't have to have a graph database for a transactional level information. So it's very important to understand in which way, if you are interested to understand relationships, right, then graph database is the way to go. Of course, you need to learn a new query language like Cypher. All right, but of course, as you can see, it is very SQL-like. We have come to the end of this particular module of NoSQL databases. So we looked at the birth of NoSQL databases, what were some of the driving factors that influenced the development and why NoSQL databases were popular. We looked at the 4 types of NoSQL database, which is your key value store, columnar database, graph database, and document database. Of the 4, we explored the key value store, columnar database, and graph database in detail, understanding the pros and cons of each of these databases and how the query language works for each of these databases. All right, I will see you in the next video. Thank you.